Okay, so little behind the scenes kind of thing. I went ahead and added these up with my handy dandy calculator. Hopefully you guys did that too. And so now that we have this in place, right? We'll just kind of like chug through, right? Hopefully you guys have read right. So we're trying to determine if there's a relationship between people who support defunding the police versus people who do not, right? So that's very key in that kind of place, right? So, the kind of formula that we, use for this, right, is called a chi-square. Chi, it's C-H-I, for those of you who are in sororities or in Greek life, right? So chi, it's an X with a stupid little curly Q right there, and it's a chi-squared, formula, right? And so what do we do for this, right? So this is sort of going to be like the bread and butter for this kind of thing. So we'll kind of walk through like how we go about this, right? So this is just kind of like the first part, right? So the first thing that we know, right? So we're just going to introduce the parts and then we'll walk through the rest of it. Is that first we know that we are going to do a summation, right? So that's what that means. So we're adding up all these different things, right? So in this case, what we'll end up doing, right, is that we're going to add up the difference between an observed value, O, so the letter O, so that would be all of these gold letters, right, that are in this box. So everything like here, 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 those are observed values in a cell, right? So like here is one cell, like you imagine like a spreadsheet, here's another, and so on, right? So let me erase that really quick, and that, boom. No, that's okay. It was 175, right? I'm going to trust y'all. That was 175. Anyway, so we have, and we'll put this back just for clarity's sake. So we have this, we take out the observed value. So that part is easy to figure out. We're going to subtract it from the expected value. In this case, the average that we would expect to see, that's what it means, right? So it's sort of like, we're basically making a guess about what that number should have been if we assume that these numbers are independent, right? So this is what we would expect to see. That's what the E means. Like, this is what we would expect to see if there was no relationship, right? So what we do here, right, so we're taking the difference between these two. So it's a deviation is another way of phrasing it, right? We're going to square this, right? So what we're going to do first is take the observed value, subtract the expected value. So what we'd expect to see if these categories were independent, right? So there's no association, square it. So this tells us, right, based off of this squaring, based off this deviation, right, is that this is always going to be a positive number. Absolutely, there's no way a chi-square value is ever going to be negative. If there's ever a negative value for this, someone did something wrong, right? So if you're calculating this kind of thing in some of the practice problems, like in the chapters or whatever, and you see this, don't worry about it, right? So we're going to square that, and then we're going to divide by the expected count, right? So we're going to take the deviation between the observed and expected values and divide by the expected values, right? So the squared deviation divided by this, right? And we're going to add it up, right? So what we really try to figure out, right, is what we're adding up, right, is what it is in each cell. So we'll walk through more of that in a second. So different question that we become formulated then is, do we just take an average? Is that how we find the expected value? What exactly is in place? So our next little bit of critical key information, right, is this expected value. So E then is going to be equal to, so the row total, right, for each, this is on a cell by cell basis, right, the cell by cell basis, right, so it's that times the column total, right? And in this case, right, the formula order doesn't matter. It doesn't matter if we put them in first, right, because it's just multiplication. It all flattens out. and then we divide by the letter n, which is the sample size, right? So remember that small n is the sample size. So where do we get it? Where are we getting these numbers right to begin with? So if we look at this R total, right, we see that if we add up across here, this is 385. So that's row total for this first line, right? This first row, and we get the second one here, it's 430 right here, right? So we move from left to right. And then we get column totals by moving up and down, right? So 175 plus 330 is going to be 505. And for here, right, it's 310, right? So that's ultimately what we would go and do, right? So this is going to be the starting point for this, right? So we're going to do this for each cell one at a time, right? So now that we've kind of introduced this, we're going to go ahead and pause, take a moment to digest this. Maybe you guys can practice a little bit and see where it is, but then we'll go about solving this